All right, I'm going to show some examples with negative exponents, but first I'm just going to do a tiny little bit of review. So anything to the 0 exponent is just 1. Anything to the negative exponent means it's the reciprocal to the positive power. So here, for example, 6 to the negative 2, that would be the reciprocal to the positive 2. And then 1 to any power is just 1, so that would be 1 over 6 squared, 1 over 36. The only thing that doesn't follow these rules is 0. 0 to the 0 is undefined, and so is 0 to the negative n. That's also undefined. All right, negative 4 to the 0. Anything to the 0 is 1. Here, this would be negative 1 times 4 to the 0. So negative 1 times 1, that would just be negative 1. Anything to the 0 is 1. But then this one, the only thing being taken to the 0 power is just the x, so it would be 4 times 1, which is 4. And now I have 1 over 3 to the negative 3. Well, that would be the reciprocal to the positive power. So it's like saying 1 divided by 1/3 cubed. 1 cubed is just 1, 3 cubed, I'll just write that as cubed just because it makes it a little, I'm going to show the shortcut here. Okay, when we take division of fractions, we multiply times the reciprocal. So this ends up being 3 cubed. If it's negative down in the denominator, bring it up to the numerator and it will be positive up in the numerator. So this is a positive 3 cubed. Okay, now on this one, this ends up being 2x squared all over y cubed. The only thing that's negative there is the y. Okay, and looking at that the long way, we would take 2 times the reciprocal of y to the positive 3 power, and then it would be x squared. 2 times 1 cubed is just 1, y cubed, and then x squared. And then if you have a number times a fraction, give your number a denominator of 1 and then multiply straight across. So we'd have 2 times 1 is 2 times x squared. 1 times y cubed would be y cubed. Okay, so if it was negative, this is negative in the numerator, it becomes positive down in the denominator. All right, so that's a little review of negative exponents. Now let's just look at our exponent rules. These are really important just to know them and be able to use them. Here, if we have x squared times x cubed, you would just add those exponents. That's just x to the 5th. Just add those. So we would have x squared times x cubed. You've got 5 of those being multiplied. Here we're going to subtract exponents. So if I had, for example, x to the 4th divided by x, x is like x to the 1, so you would just subtract those and get x cubed, and that's because you would have 4 in the top, 1 in the bottom. Anything divided by itself is just 1. So you take basically this 1 in the bottom and cancel it out with 1 in the top and just end up with x cubed. Just subtract exponents when you're dividing. And now for the power rule of exponents, if I have, for example, x squared taken to the 3rd power, you get to just multiply 2 times 3 and get x to the 6th, because that means cubing means take that times itself 3 times, and what that is x squared. So I would have 3 sets of x squared, so that would be x squared, or sorry, x to the 6th. All right, and now if I have something like 2x and I'm taking and cubing that, you get to cube every part of that product inside the parentheses. So this would be end up being 8 cubed. 2 times 2 is 4 times another 2 is 8. And now if we have a division like 4 over x, and that's all being squared, you would get to square everything in the numerator, square everything in the denominator. So that would be 16x squared. All right, so now we're going to do 3 more complicated examples. Okay, here we go. On this one, first I'm going to simplify my numbers a little bit. Any fraction is just a division problem. So negative 15 divided by 5, that is negative 3. And now I see that I have, let's see, the way I look at this is I would see I have all these negative 3's on the top. They're going to come down and be positive down in the denominator. And then I have c cubed, and I'm going to subtract that c from the top. So we would get negative 3 over a times c squared. That would be the answer. Okay, another way of looking at this is that we would have that same negative 3, and then you would take a to the negative 3 and subtract whatever's in the denominator. And then I would have c, this is like c to the 1, so c to the 1 minus whatever's in the denominator. So that would give us negative 3 times, this would minus a negative, this negative means add the opposite. The opposite of negative 2 is positive 2. And then c, this would be 1 minus 3, that's like what, plus a negative 3, so it would be negative 2. We get negative 3 times a to the negative 1, c to the negative 2. These negative exponents mean that those, we're going to write the reciprocal to the positive power. 1 to any power is still 1, so it would be negative 3 times a, 1 over a. 1 squared is still just 1, and then c squared. And then you would just multiply your number times your fractions, multiply straight across in the numerator. Negative 3 times 1 is negative 3. 1 times a is just a times c squared. So that's kind of the long way to do it. All right, on this one I'm going to apply the power rule of exponents. So here I am squaring everything in that first parenthesis. So I'm going to take the negative 2 and square that. I'm going to take the h squared and square that. And now on this one, I'm going to take everything to the negative 2 power. So I have 3 to the negative 2 power, and I have h to the negative 3 to the negative 2 power. Okay, so from here, negative 2 squared, that means negative 2 times negative 2, so we get a positive 4. And then h squared squared would give me h to the 4th, because this means h times another h times h. Okay, and now I have this, I would write the reciprocal of 3, so 1 over 3 to the positive 2 power. And now here, when I can just multiply these exponents, so I would get a positive 6 there, so it would be h to the positive 6. And so my final answer here, I've got 4 h to the, let's see, I can combine these. So I'm going to do h to the 4th and then times this h to the 6th. I'm just going to bring those close together. That's going to just end up being h to the 10th. But let me deal with this. 1/3. Okay, 1 squared is just 1. 3 squared is 9. So I would get 4 h to the 10th, right? Because h to the 4th is h times h times h to the 6th. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just get to add those exponents. And that's times 1/9. You can think of that like a whole number times a fraction. Multiply straight across in the numerator. 1 times 9 is 9 in the denominator. So that ends up being 4 h to the 10th over 9. Okay, on this one I have this negative 3 exponent. But first I'm going to just clean up inside my parentheses here. So let's see what I have. I can't simplify the number 2. There's no numbers in the denominator, so that stays at 2. But looking at my a's, I've got a's in the top and a's in the bottom. I have more a's in the denominator, so I'm going to take those 6 from the denominator and subtract the 3 from the numerator. Okay, now for my b's, I have negative b's down in the denominator, so I'm going to take the b squared from the numerator, and I'm going to add those 4 from the denominator, and then nothing's happening to my c. And I know I have to take all that to the negative 3. But let's see what we have here. We've got 2 and then b to the 6th times c in the numerator, and then it would be a to the 3rd in the denominator. That's taken to the -3. And now I can write the reciprocal to the positive power. So what used to be in the denominator, the a cubed, is now going to be in the numerator because I'm doing the reciprocal, so you just flip that upside down. And so the 2b to the 6th c would be in the denominator. And now I get to apply that cubing to everything. So it would be a cubed cubed, and then 2 cubed, b to the 6th cubed, and c cubed. So my final answer here, I get to multiply powers. Here that's the power property of exponent. So I would get a to the 9th. And then 2 cubed means 2 times 2 times 2, so that's 8. And then here I have b to the 6th to the 3rd power. I get to multiply those, so that's b to the 18th, c cubed. So there's my final answer. Done and done.